Welcome to our first proof. I'd like you to already be familiar with the formula for circumference, which is the distance around the outside of the circle. The formula is 2 pi r. So 2 pi r measures, if you were to start here and imagine it like a tire and you were to go the full way around. If you need to find your pi button on your calculator, it's here. Now, what we're going to do is we're going to examine what is a radian. A radian is an alternate way to measure an angle. Just like we have kilometers and miles, and there are two different ways of measuring length, we have degrees and radians, which are two different ways of measuring angles. You'll notice on your calculator as well, if you press here, set up, you'll have degrees and radians. So depending on your question, you might want to familiarize yourself with how to switch between those. Now, to work out a conversion factor from degrees to radians, for example, we know that roughly 8 kilometers is 5 miles. So we have a conversion rate. When we travel the full way around the outside of the circle, we cover the full circumference, we would actually cover 360 degrees. That's a full circle. So if we compare the angle to the length, the angle is 360. The length that we're going to cover on the outside is going to be 2 pi r. Now, the official definition of a radian is that a radian occurs when this arc length here is equal to the radius. So you can see that's the radius and that's the radius. And when this is also the same length, the angle formed here would be 1 radian. So the proportion would be, the angle would be 1 radian if the length that's traveled along the circumference would be 1 radius. Now, if we want to compare the two systems, we need to compare like for like. So what we're comparing here is 360 degrees is a length of 2 pi r. So in order to be comparing the same length, which is 1 full revolution, we would need to multiply this ratio on both sides by 2 pi, because then r times 2 pi would be 2 pi r, and we're comparing like for like. Now, when we multiply 1 by 2 pi, we're going to get 2 pi. So it's fair to say that 2 pi radians is proportional to the full circumference, or 2 pi r, and 360 degrees is proportional to 2 pi r also. That must mean that 360 degrees is equivalent to 2 pi radians. And we can simplify down that ratio slightly by dividing both sides by 2. That gives us a final conversion rate of 180 degrees is equal to pi radians. The second way to think about it is if a full circle is 360 degrees, every time we move a distance r along the circumference, the angle measured is 1 radian. So we need to think about how many radians would make up that full circle. But we know that the distance around the outside is 2 pi r. So it must be true that 2 pi radians would be a full circle, because if we times this by 2 pi, we would get back to the start because we would have the formula for circumference. So you can think about it in either way, but it's important to remember that 180 degrees is equivalent to pi radians. That wraps up the first video. So what I'd like you to understand now is that radians is an alternate system for measuring angles, how to change it on your calculator, and why it's true that 360 degrees is the same as 2 pi radians. In the next video, we're going to be looking at converting between degrees and radians and degrees.